This is how our directory looks like. Inside the server, we have the node modules, public, source, and these files. Go into the source and into the configuration. We created this file db.config, but we need to rename it. It has to be db.config.js. So you can do the renaming here. We are going to set up for the PostgreSQL. We need to first give the credentials of our database and export it. Module.export, and inside this object we will give a few credentials. The user will be Postgres. We will add the host, give the name of the database. We will call it home. The next thing is to add a password. Just create any random password that you want for your database. I'll use this, and the port is always 5432. Once you are done, go to the modules, and inside the modules, the db.js. So this is where we are going to create an object that will help us to connect to the database. We are going to require the PG, that is for Postgres. And also we will get the db config that we just created. So let's try to access that config/db config. Constant pool, and we are going to create a new instance of this pool that we got from the Postgres. So you do this and you leave space. Inside here we call user, and the user that we created in the db config, we call host dbconfig.host database, call the password, and we call the port. You bring a semicolon. When the database is connected, we can print something. So on connect, we can write something to the console. Now in case there's an error, we can also print something to the console. Error on the client, you can print the error and exit. After everything, Node.js application, we always need to export, and this export will be the pool object that we created. This is a concise program here that will allow us to have access to the database. From this, in the same directory, I want you to go to the census.model.js. A module is going to describe the fields in our database and the operations that we would like to do in the database. So for example, we would like to insert something into the database. We would like to find something by an ID. We would like to delete. We would like to update. All those things we are going to describe in the module, so that later on we can reference the API and we don't need to rewrite the queries manually. We will call the pool that we created here. So on top, let's call constant pool. They are in the same directory, right? So db. The first function is we have to create the table that we want to have access to. When you go inside the database, we have tables. In case the table is not created, then you have to create it, and we call it create sensor data table. We have to make it asynchronous in case it has to wait for a response. Inside here, we will write a query to create table, and so we can do constant query like this. As a convention, we have to write in capital letters, but you can also write in small letters. We do create table, and the name of the table will be sensor data. We need to bring this. Let us define the fields in the table. So first, this sensor data table will have an ID, primary key, so that it will keep on increasing, and it has to be unique. We will have a field for timestamp, so that anytime that we send data, it will get the timestamp of that particular moment and save it in the table. We will call an inbuilt function called timestamp default now. Now the next field will be for recording the temperatures, and this will be numeric. We will create the field for the pressure, the field for air quality, and also for the light intensity, which will also be numeric. We will just call this function here. So this function will be called automatically in case the table does not exist. So we say create table sensor. Let's add if not exist. If we already have the table, then we want to create it again. The next function that we want to create is a function that will go into the database and query all the data that we have. So we can do const get all sensor data. Now we are going to do a try and catch. Let's put an error. If there is an error, we will throw that error. Throw new error. Now inside the try block here, we can do constant result. We call the pool object and we pass in the query. We want to select everything. To do that, we write select star from sensor data, and we will return all the rows. The next function will be to get a specific row of sensor values by the ID. Get sensor data by ID. It means that we have to pass an ID to this. Make sure you bring your semicolon. Inside here we will do try and catch. So now constant result, we will do await pool.query. And this time the query to select a row of data by an ID, we write select star from sensor data, where ID is equal to the ID that we want to add, right? We will do *1. We go outside here and we put this in bracket ID. Once we have this, we can do return. This time we only need one value, so we get the first row, and we have to do the catch the error. Now, something that we would like to do with this project is that we want to enable the user who is accessing the web client to input a time range in which he wants to see the sensor data. So you go to the website and you type, let's say 1,5. It means that you want to see the sensor values that has been recorded between the past 1 hour and 5 hours. So let us write the query for that. We can say constant.get sensor data within range async. So this time we need to give it the time range that we want to query the data. Bring your semicolon. Let's do a try block here. We're going to do select star from sensor data. This time we will use the where clause. Now if we look at our database, you can see we have a timestamp field, so we are going to use that. So where the timestamp, we want to find the timestamp between certain period of time, right? Let's go to the next line and do timestamp between now, and we need to subtract. Let's get the time that we passed here. This time we get time end. So this is going to be an object. So that object will have a field that we call time end. It will be in hours. Okay, let's continue the query. Let's go to next line. Now we will get the time start. So now minus interval. We do the same thing. This time is going to be time start, also in hours, and we will bring a semicolon. This query will do that for us. It will get the sensor data within a specific range. So now we can get the result like we did for the previous. Await pool.query, and we pass in the query. Once we get it, we can return the result, and this time it's going to be a lot of rows. We will return everything. Now let's catch the error. The next function will help us to insert sensor data into the table, right? And also we will create a function that will delete a row from the table. So the function to insert, we will call it create sensor data. This will be async. And when we are creating a sensor data, we need to pass the data that we want to create, right? So this is going to be a post request. You send a post request with the key value pairs. We will do this. Make sure you bring your semicolon. So inside here we will try and catch. So we're trying, we need to get the query. We're going to insert into the sensor data table. We'll get the field that we want to insert to. We get the temperature field, pressure field, the air quality, and the light intensity. Now come to the next line and the values that we want to insert. The values we want to insert will be coming from this. So this is going to be an object. So we are going to call this object, and we will get all the fields that we want to insert here. In PostgreSQL, you can just represent them with numbers. We have 4 values to insert. After creating it, we want to return the object that we created. So we will add this. Once you are done here, let us get the objects that we want to insert. That is the fields that we want to insert. Let's put them into like an array. We can do constant values, right? Going to be an array, and we will pass the field from it. So this is temperature here, data dot. The next one is pressure, air quality, and light intensity. Now this, as I said, is going to be a post request, so make sure that the fields they match this exactly. Other than that, it will return an error. And we can do constant result, the same as the above. Await pool.query, and this time we will pass in the query that we just created above, and also the values. So we get the results and we can return it. We are creating one object, so we get the first index and we throw it. The last function that we create is a function to delete a field in the database. So as usual, let's say delete sensor data. Sync. Now when we are deleting sensor data, it means we are going to delete a specific ID. So let us pass the ID here, except you want to delete everything inside the sensor data table. This is not what we want to do. Bring your semicolon. We do try and catch any error. The query is delete from sensor data, where the ID is equal to, we will return the row that we deleted. So bring comma inside and also outside, bring comma, right? So once we have this, we can do results. Once again, we call the pool object query and we pass in the query, and also we need to pass the ID that we want to delete. Okay, then we return it. We are only deleting one, so we get the first index. Then we can catch any error. So we can do module.export. So first we export the get all sensor data, get sensor data within the range, literally all of them except creating the sensor table, and also delete, comma. Now that is it for the sensors.module.js. From here we will go inside the services and we will write the code for the sensors.services. So the sensors.services is going to require the functions that we created in the module. That is why we exported it. We create all these abstractions and it makes it easy for us to manage the database. Go to the sensors.services.js, which is inside the services directory.